Today we will talk about the science and politics of climate change. So far the focus has been only on science of climate change because that was the main goal of this course. But you cannot avoid talking about politics because science and politics get mixed up in this issue. You may wonder why. Many people think science and politics are two distinct areas and they should never be together. But it is important to remember that science is never partisan, it is always objective, but science is always political. Why is that? It is political because new knowledge either confirms or challenges vested interest. The best example of this is the story of Galileo. When Galileo announced that Earth goes around the sun and not vice versa, he was condemned and the authorities at that time forced him to admit that he was wrong. Why did they do that? Because it challenged the paradigm that existed at that time. So, this clash between science and politics will occur now and then in the history of our civilization, because sometimes science does bring knowledge which makes many people uncomfortable. Okay? Now, because climate change caused by human beings poses a threat to the fossil fuel industry and the countries whose major revenue is the export of fossil fuels. So, more than 40 years ago, these countries got worried that if human induced climate change is accepted as a reality, then there has to be a cutting down of fossil fuel burning. That will mean almost 10 countries in the world whose economy depends on export of fossil fuels will be in deep trouble. So, they encourage climate change deniers to make these statements which I mentioned earlier, that there is no global warming, humans are not responsible, even if it occurs impacts are minimal, and even if impacts are large, it will be too costly to mitigate climate change. Okay? So, the purpose of this course is to give you the scientific background about climate change so that you can respond to these excuses. And to do that, you need a good understanding about what controls Earth's climate. That was the purpose of this course. Okay? Today, I will review some of these things and the politics that resulted in it. Okay? For example, more than 10 years ago, the first Indian edition of the Wall Street Journal said, "No need to panic about global warming. There is no compelling scientific argument for drastic action to decarbonize the world economy." So, this was an effort by the fossil fuel lobby to create the impression that global warming is not a serious issue. Okay? And they were not the only people. Secret funding helped build a vast network of climate denial think tanks, and billionaires who gained by the sale of fossil fuels donated more than $120 million to 100 anti-climate groups to discredit climate change science. Okay? This was shown by The Guardian more than 10 years ago. Okay? So, that is why if you do a Google search for climate change, you will get many websites which will pretend that climate change is not a serious issue. Okay? So, these are fake websites paid by somebody. Now, the best example of this controversy is the so-called hockey stick controversy. That is, the work done by Professor Michael Mann in Pennsylvania State University. He used proxy data, which we discussed in this course, mainly tree rings, to show that temperature was below the 20th century for a long period, from 1000 AD to almost 1850 AD, and then it began to rise rapidly. Okay? This was a very important paper which showed clearly that climate change occurring in the 20th century is not due to natural causes. This variation is due to natural causes, okay, from 1000 AD to 1800 AD. So, once this paper appeared, the entire fossil fuel lobby attacked Michael Mann, okay? And he had to undergo many challenges. He lost his job in one of the universities, and he has written about his experience in this very interesting book called The Hockey Stick and the Climate Wars. Okay? The word hockey stick comes from the shape of this curve. This curve is shaped like a hockey stick. Okay? So, that is why it is called the hockey stick curve. Now, Michael Mann has written many books showing how the fossil fuel lobby is creating confusion about the climate change issue. Okay? So, I recommend strongly that all of you should read the book The New Climate War by Michael Mann, published about 2 years ago, in which he says a consortium of fossil fuel interests known as the Global Climate Coalition, which included ExxonMobil, Shell, British Petroleum, Chevron, American Petroleum Institute, and others, came together in 1989 to challenge the basic science of climate change. So, this book gives in great detail how they went about creating confusion, creating doubts about the climate change occurring due to burning of fossil fuels. Okay? Now, Michael Mann says the fossil fuel industry has been granted the greatest market subsidy ever, the privilege to dump its waste product carbon dioxide into the atmosphere at no charge. So, this industry worth more than $1 trillion has benefited from this market subsidy and is not willing to permit the reduction of burning of fossil fuels, which is necessary to control climate change. Now, we should learn a lesson from ozone hole, which we discussed in this course in one of the early lectures, that in the 1970s, scientists showed that ozone will decline steadily on account of chlorofluorocarbons. But what actually happened was a catastrophic decline in Antarctic called the ozone hole. Okay? So, what you should realize, in spite of our very good understanding of Earth's climate system, our predictions can be too optimistic. The real situation can be much worse, because Earth climate system is very complex and we not able to model all the complexity. So, there is always a surprise like the ozone hole that can happen when it comes to global warming. Now, because the ozone hole appeared suddenly out of nowhere, it created a big concern, and very soon the Montreal Protocol on substances that deplete ozone layer was agreed upon on 16 September 1987 at the headquarters of the International Civil Aviation Organization in Montreal. This is a very famous protocol which resulted in phasing out of chlorofluorocarbon and other chemicals which cause ozone depletion. Okay? And this was possible because at that time the President of USA, Ronald Reagan, decided that he will support this protocol, and this whole interesting story is mentioned in a book written by Richard Benedict, who was involved in the negotiation, and he showed how the leadership provided by USA resulted in this protocol. But you must remember that the success of this Montreal Protocol does not mean a similar success will occur in the case of climate change, because it is a different problem. Now, this can be compared. Ozone depletion is on the left column, climate change is on the right column here. When ozone depletion occurred, only 20 countries were involved because they were the one contributing most to the ozone depletion. And there was clear scientific evidence from the ozone hole. We have not found that clear-cut evidence of a disastrous change yet. Okay? And ozone hole would have affected all countries in the world, while in the case of global warming, some countries like Russia will benefit somewhat from the warming, but most countries in the tropics will lose. Okay? So, in both cases, the United Nations had scientific assessment panels, and which made a clear conclusion that both the depletion of ozone and global warming are serious issues. In the case of ozone hole, United States provided the leadership, and being the largest contributor to ozone depletion, it helped. In the case of climate change, the European Union is putting leadership. Unfortunately, United States is not helping. Okay? United States opposed Kyoto Protocol 95-0 in a vote in the Senate, while in the case of Montreal Protocol, it was approved 87-0. Okay? Now, in the case of ozone hole, the cost of developing substitutes was not very high, so the switch was easy, but this is more costly. To replace fossil fuels by solar, wind and other renewable sources is happening, but it will take much more time. Okay? So, in the case of ozone hole, developing countries were considered as the major, not the major contributors. So, they were provided aid to reduce ozone depletion. But here in the 1990s, developing country like China was considered as a competitor to Europe and USA. Okay? And so, this big difference made that although Montreal Protocol was successfully adopted, the Kyoto Protocol, which is the equivalent to the Montreal Protocol for global warming, is still struggling. Okay? Now, the problem is that Earth climate is always changing. Okay? You have to distinguish between natural climate variation, fluctuation, which change from year to year due to energy exchange between ocean and atmosphere, from that is called internal variability, from the outside effect caused by human beings, which is over and above the natural climate variation. Okay? The natural climate variation is the well known El Nino Southern Oscillation phenomena, which occurs every 4 to 5 years, which is a natural climate fluctuation, and the global warming is on top of that. Okay? So, one has to differentiate between the signal of human induced climate change from the natural fluctuation which is occurring. So, how do you do that? So, to show the impact of global warming, you have to show how much additional risk is caused by global warming. This is called the fraction of attributable risk. And this was defined more than 7 years ago. And this is based on this kind of figure. Imagine rainfall distribution. Black is the observed value of rainfall distribution in a given region, and blue is the variation in a model which does not have a CO2 increasing. It is called natural. It is not identical to the observation because models are not perfect. But in that model, if you put an increase in CO2, the distribution shifts, which we discussed earlier in this course. So, because of the shift due to increase in CO2 of the rainfall distribution, the chances of very high rainfall, which let us assume is this, we choose a line, vertical line, above which the heavy rainfall will cause serious damage. That possibility has a certain area under the curve for the natural variation, which is in the cross hatched here, and the area under the curve due to CO2 increase is this red line, this one, okay. And you take the ratio of these two probabilities, that is called the fraction of attributable risk, okay. How much attributable risk is increasing due to global warming, okay. And that you can now compute for every extreme event like heat wave and extreme rainfall, droughts, landslides, all of them you can calculate this. So, you can quantify the additional risk we have to face on account of global warming. Now, when you do that, you can do it for global mean temperature, decrease in sea ice, or you can do event attribution, that is extreme event occurring in, let us say, Europe, heat wave which we saw, okay, or more extreme cyclones, or extreme rainfall, or wildfire which we saw was one of the impact of global warming, okay. So, these have been discussed. This attribution is a very important issue, because in order to pay for the damages of global warming, we must be able to show that this event probably increase dramatically on account of global warming, okay. So, in December 1997, we had the Kyoto Protocol, which is similar to Montreal Protocol, which was done in 87. There the 38 industrialized countries agreed to reduce their greenhouse gas emissions by 5% between 2008 and 2012 compared to 1990. Okay. But unfortunately, this protocol was never actually implemented, because there was a collapse of the protocol, because United States decided, as I pointed out in a slide, that they will not agree to Kyoto Protocol, although they signed it but did not ratify it. Okay. So, this was a major breakdown in the climate negotiation which is going on from 1987. Now, finally, the Kyoto Protocol was diluted substantially, and we had the Paris Agreement in 2015, signed in 2016, which has no binding provisions that was there in the Montreal Protocol for ozone depleting substances. Okay. Now, we only have voluntary provisions, which we do not know whether it will be actually implemented. Okay. So, that is the background for the politics of climate change. Now, let us review what are the major issues that we discussed in this course. First, we said it is important to differentiate between fluctuating weather, which all of us understand on a daily basis, with natural climate variation, which changes from year to year, and human induced climate change due to increase in carbon dioxide. So, among many people there is a lot of confusion. I hope those of you who are taking this course have a better understanding of this difference. Okay. Other thing is important to understand a difference between natural climate change due to changes in solar input or volcanic eruption with human induced climate change, which is due to either increase in carbon dioxide or increase in air pollution. Okay? And then we have differentiated between local and global. There are a lot of local climate change going on for which there is no global cause. Okay? So, it is important to understand that also. Okay? Global change is caused by changes in ice cover, clouds, gases that absorb earth radiation, and changes in incoming or volcanic eruption. All those are global causes. There are many local causes. Local cause can be due to change in wind direction, which can be natural or human induced, or change in land use pattern. When you convert a forest to an urban area, that is a huge change, or it can be local air pollution. Okay? Now, the anthropogenic climate change has 3 scales. There is a small scale like urban heat island, where we convert green area into urban land with a lot of concrete and the area heats up substantially. That is a purely local factor which can be addressed by local laws. Then large scale conversion of forest to agricultural land, which has occurred over the last 10,000 years in Earth's history. That is a land cover change, that is larger scale than urban heat island. Then global scale, which is greenhouse effect, where we have released CO2 all over the world, but that is now there everywhere in the planet. Now, the process of establishing climate change without assigning any specific reason is known as deduction. We detect climate change as being a signal above the noise of natural climate variability. Okay? After that comes attribution. Once you detected climate change, you have to decide what is causing the climate change. That is the attribution. These two are 2 different things. Okay? So, because of the presence of natural climatic variability, you have a signal in noise problem. The natural climate variability is a noise which we have to live with. On top of that, a signal caused by human induced climate change. Okay? So, you use statistical techniques to differentiate between signal and noise, okay? And that has been done. We have not discussed that a lot in this course, but to understand that you need a good background in statistics. Now, this is addressed in great detail in the 3rd assessment report, chapter 12, about how to detect climate change and how to attribute the causes. One example we saw in this course was that the observed global increased temperature, that is a black line, can be only explained with a climate model if we allow CO2 to increase as per observation. If the model is run without CO2 increase, we get this almost steady state fluctuation, natural climate variation. So, this was a good use of a climate model to demonstrate the impact of CO2 on climate change. Now, after that comes attribution. Why did the global mean temperature increase? That was done by comparing the observed increased temperature in black line with the model predicted climate change due to increase in CO2. Okay? And there are a lot of simulations and we average them. So, the ensemble mean shows a clear difference between the simulation with higher CO2 and simulation and observation. Okay? Simulation with no CO2 increase we saw already was a horizontal line. Okay? So, this is the attribution problem, which shows clearly that CO2 is the cause of the increase in global mean temperature that we observe. Okay? Now, one more thing is called fingerprinting. Now, when CO2 is increased, it causes warming in the stratosphere, in the troposphere, but cooling in the stratosphere. This is a unique fingerprint of increasing greenhouse gases, which we have discussed in this course, and I am comparing that with what will happen if solar radiation increase. If solar radiation increase, you will see only warming in the troposphere. You will not see much change in the stratosphere. Okay? We saw that that is due to the fact that in the troposphere temperature is decreasing with height and stratosphere is increasing because of the ozone layer, and that causes a difference between the way greenhouse gases warm the troposphere and cool the stratosphere. Okay? So, the fact that we have now observed warming in the troposphere and cooling stratosphere shows that we are the fingerprint of the impact of human induced climate change. Now, you may all ask, why do we focus so much on the global mean temperature? That is because global mean temperature can be easily related to imbalance between absorbed solar and emitted radiation from the earth. Okay? And this imbalance causes the increased temperature, and this is due to a global cause, not a local cause. For all governments of the world to come to agreement, it is essential that we have a global metric like the global mean temperature, and everyone realizes that the increase in global mean temperature is caused by actions of all human beings, and everyone has to now cooperate to reduce this emission. Okay? So, for this purpose we need to focus on global mean temperature, although we do not live in the global mean, we all live in various parts of the world. So, global mean should not really bother our local climate, but it is necessary for the global negotiation. Okay? Now, we saw last year 2023 that the temperature of the world global mean was higher than 1.5 throughout the whole year July 23 to June 2024. This is the first time all the months showed a temperature higher than all the previous years starting from 1850 to present. So, it clearly demonstrated the role of human beings in controlling the global mean temperature. Now, we use the simple model proposed by Professor K.N. Liu, in which showed that the global mean temperature depends on incoming solar radiation, radiation reflected by the Earth atmosphere system, radiation absorbed from the sun, and the emissivity of the atmosphere. So, we are able to show that the global mean temperature depends only on 4 parameters: incoming radiation, radiation reflected, albedo, radiation absorbed, and emissivity of the atmosphere. So, this enabled us to understand how changes in these quantities affect the global temperature. The other thing I highlighted in this course is understanding of Kirchhoff's law. Kirchhoff's law says emissivity and absorptivity are equal at a given wavelength. It does not say emissivity and absorptivity are equal when you average all wavelengths, because when we consider the incoming solar radiation, we have to look at the region 0.4 to 4 micron, where the average absorptivity is around 20%. When you look at the emission from the Earth atmosphere system, the radiation between 4 micron and 100 micron, that the emissivity is 0.95. So, the total emissivity of the Earth system is 0.95, but the absorptivity of the Earth atmosphere system is 50%. Okay? So 20%. So, the point is that emissivity and absorptivity are not equal if you average over all wavelength, they are equal only at a given wave. That is an important point to understand. Then we took this equation and differentiated and showed how sensitive Earth temperature is to incoming radiation, to change in the solar absorptivity, change in the reflectivity, and the change in the emissivity. Okay? And so, all these help us understand how the Earth's radiation changes in response to these changes. Okay? And we also use a graphical way to illustrate how the emission of radiation from the Earth and the absorption intersect at 3 points. These are the 3 possible solutions. We are in this climate now, and about 20,000 years ago we were in this ice age, and 600 million years ago we were in a snowball Earth. All the 3 were possible, and we happen to be in this present state. So, I will continue this talk in the next lecture. Thank you.